Hello everyone, my name is Jinhua Hong. This is my concrete comprehensive strength project. First, I'm gonna do some background introduction. Concrete is the most widely used building material around the world due to its various advantages. Many prior studies has been done to predict concrete comprehensive strength using machine learning methods. I'm gonna use this paper as a reference paper to compare my results with their results. The research questions are, among all these 8 variables, which variables can predict concrete comprehensive strength? And among all these 8 variables, which predictor has the biggest impact on the concrete comprehensive strength? The reference paper can be accessed here. Next section is the data description. Based on the table, we can see there are 8 independent variables highlighted in blue and 1 dependent variable highlighted in yellow. We can also see the descriptions and ranges here. The sample size is 500. And I also recoded the variables like this. Next section, I'm going to do preliminary analysis. The first model I use is the first order model with all variables in the model. The model is like this. Based on the summary output, we can see that superplasticizers has no significant impact on concrete comprehensive strength. Then I did the assumption check. Based on the results, we can see that there is a violation on normality but not on constants. So in the later model selection, we might consider transforming y or x or both due to the violation on non-normality. Then we check the residual plots. We can see that H residual plots is not normally distributed. Next, I check the added value, and based on the figure, we can see that superplasticizers has no added value. Then I check the multicollinearity. Based on the correlation matrix, we can see that the correlation between water and superplasticizer is 0.67. It's a little bit high. Then we check the VIF to see if it has significant impact. All the VIF is not greater than 10, so we can conclude that no multicollinearity problems in this model. Next, I check the outliers. Based on the figure, we can see that there are several outliers. And then we check in the table that there are no outliers on Y, but there are several outliers on X. And there is no influence case based on the Cook ID. Next, I did the best subset analysis. Based on the results, we can see there are 2 models that are acceptable. The last model with all variables and the 7th model with only dropping the superplasticizer. The full model has the largest R-square and R-square adjusted and the best Marlow CP. And the 7th model has a still good Marlow CP and the lowest AIC and the lowest press P. So in the later model selection process, we can consider these 2 models, which are the full models and the model without the superplasticizer. So the model 2, I try to box transformation on Y and with all the variables inside the model. The model is showing like this. Based on the summary results, we can see that still the superplasticizer has no significant impact. And the assumption checks, we see that the violation on normality is still not solved. So then we try to do other step. Since that's based on prior residual plots, there is some problems with the age residuals. Then in model 3, we do the box transformation on Y and we log the age. The model is showing like this. Based on the results, we can see that superplasticizer is still not significant. And then based on the assumption check results, now that the normality check passed, but we have an equal constant now. Then looking at the residual plot, we see that log age in residuals is improved a lot, and now we have a almost normal distributed residual plot. Then the next model, based on the best subset analysis, we try to drop superplasticizer. The model is like this. Based on the summary reports, we see that all variables are significant. And then by checking the assumptions, we see now that normality check is still not passed, but we have equal constants. Then move on to the last model. Due to the non-normality problem and the age residual problem and the best subset analysis, I decided to do box transformation on Y and log age and drop the superplasticizer. Based on the summary outputs, we see that right now all variables are significant at 0.001 level. And then by looking at the assumption check, we see that we solve the normality problem and we have equal constants. We're good with the assumptions. Then by checking the multicollinearity, I check, since we check the variables, all other variables correlation except the log age. And right now I only check the newly added variable log age correlation with other variables. All VIFs showing less than 10. Then looking at the residual plot, we see that the log age residual plot has no problem. Then the last check is the outlier. Based on the picture, we see that there are still some outliers. We can also see that in the table. Although we have no outliers on Y, but there are still outliers on X. The 10th case and the 36, 200, and 302 cases, these are the outliers on X. And we have no influential cases based on the Cook's ID. Since we have outlying problems, I decided to do a robust regression. The result is showing like this. And the model can be written like this. Then when we compare this robust regression with OLS, we see that robust regression is better. And based on the results, we can see that log age has the biggest coefficients, so it has the biggest impact on the concrete comprehensive strength. We can say that log age is the best predictor. Now move on to conclusion. The final model is showing like this. Now we can answer the research question that cement, water, coarse aggregate, fine aggregate, blast furnace slag, fly ash, and current type has significant impacts on concrete's comprehensive strength. And in this model, we have no assumption violation on normality and constant, and no multicollinearity problem, and the outlying problem has been solved. In this model, the best predictor is log age. The last step, I'm gonna compare my results with machine learning methods results in the reference paper. And in my result, we can see that the R-square is 0.831 and the adjusted R-square is 0.8286. Then we see the in the reference paper using various machine learning methods. We can see even the worst method, which is SVM, has a R-square 0.855, which is greater than my results. And the best method they're using is ADA Boost with a R-square 0.982. So now we can say that using machine learning method has higher accuracy, and also the model has better explaining power on the concrete comprehensive strength. That's all my presentation. Thank you all.